Hello everybody, and welcome to our video on graphs of quadratic functions. And just like go ahead and just jump right into this video lesson. Let's just note that the function of the form f of x equals x squared is a very interesting graph. Again, we can construct our x and y coordinates. Maybe go -2, -1, 0, 1, 2, and let's just note that we plug this -2 over here into x squared, I get 4, and -1, plug it into this x squared, we get 1, and 0, get 0, and then plug a 1 in here and we get 1, and plug a 2 in, we get 4, and so forth. And let's see, the interesting thing is if we go 1, 2, -1, -2, 0, 1, 2, 3, 4, 5, 3, 4, 5. So at 0 we get 0, and at 1 we get 1, -1 we get 1, and at 2 we get 4, and at -2 we also get 4. And if we take a look at the graph of x squared, the graph of x squared looks like that. And this is this type of a graph is what we call a parabola. A parabola is just a fancy word for a bowl-shaped sort of graph. All right, so the graph of x squared, no matter what, is going to look like this. So what we would like to do is to take a look at how different constants has an effect on the graph of x squared. So the idea is we would like to take a look at x squared and what happens when we add, say, 3 x squared, and say what happens when we subtract 4. How does this have an effect on x squared? And then we'd like to take a look at another one, say x minus 2 squared, and say maybe x plus 5 squared. And how does putting this constant inside the squaring, how does this have an effect on the graph of x squared? There's a couple of properties about the parabola that is true. And one of the things I'd like to take a look at is this point right here. This point is what we call the vertex. Okay, the vertex is right here. And another interesting fact about this paraboloid is that if I draw a line right here in the middle, that notice that this point and this point are mirror images, and this point and this point are also mirrored images. So the vertex here has the coordinate 0, 0, and this line right here, this guy right here, is what we call a line of symmetry. So the vertex for x squared always has the coordinate 0, 0, and the line of symmetry which I will refer to as the LOS, notice is a vertical line, and it's a vertical line and it has the equation x equals 0. So the idea is that this vertical, red vertical line for the line of symmetry is just a mirror. So notice that this side is a mirror image of this side. So this graph has a sense of symmetry to it. This is a property that you'll discuss a lot in your college algebra course, so we're just going to kind of introduce it here. Now, these what we're taking a look at here with these guys and how it has an effect on the graph of x squared is also something that you're going to discuss next semester as well in your college algebra course, and that the idea is that you're going to expand this to other types of what we call a basic library of functions. So not only are you going to look at x squared, but you're going to look at absolute value of x, square root of x, cubed root of x, 1 over x, and a few other ones. So knowing what these parameters do to the graph of x squared will definitely translate over, and you'll see it again next semester when you take your college algebra course. So in the meantime, let's just go ahead and take a look at x squared. I'm going to go ahead and change my ink. Take a look at x squared plus 3, and let's just take a look and see what this has to do with our graph and then we'll take a look at x squared minus 4 and take a look at that. Now you can go through your reading and in your textbook and you will have a sense of what's going on from that point of view. But I think, you know, that a picture is worth 1,000 words. So what I'd like to do is to go ahead, and I'm just going to use this graphing calculator, and let's just take a look at the picture and see if we can't come up with some generalized conclusions here. Okay? So I'm not really worried so much about you following along and learning how to use this. Eventually you will. All right, but right now I'd like to go ahead and just put in x squared. So x squared. All right, and now what I'm going to do down here, I'd like to go ahead and put in x squared plus 3. So x squared plus 3. And I am going to make this graph, the x squared plus 3, I'm going to make this a thicker line. Okay, so x squared plus 3. So let me just take a look-see here. Again, don't really worry too much about what I'm doing here. So I'd like to go -5, 5, 1, 0. Okay, now let's take a look at some graphs here. So there's our graph of x squared that we just taken a look at. And here's the second graph. Our thicker graph is x squared plus 3. So can we agree that it looks like our graph was shifted up? Okay, our graph was actually shifted up 3 units, as we can see right here, 1, 2, 3. All right. So the question now is, when I take a look at x squared plus 3, how this has an effect on the graph of x squared. The idea is that maybe this number takes our graph of x squared and will shift up. So we can kind of think of this as a shift up parameter, this many units. And let's just notice that the vertex now has coordinates 0, 3. So the vertex changed from 0, 0 to 0, 3. All right, so notice that this thing just moves straight on up right there. So what do you think? Can you care to take a guess on what happens if we subtract the 4? How that's going to have an effect on the graph? So while you're pondering that, let me just update here and just go -4. I'll change my windows here. And I'm going to bring this. Now let's take a look at the graph. There's our graph of x squared, and notice our graph of x minus 4. So does it appear that our graph then was shifted down 4 units? So maybe when we take the graph of x squared and we subtract off a number, this is a shift down. So I guess, and notice that the vertex for this one is 0, -4. So if we take this graph and shift it down, then that's going to have an effect on the vertex. Let's just notice that the line of symmetry, notice that since we did not shift to the left or to the right, the line of symmetry is still x equals 0, and the line of symmetry here is still the line x equals 0. Okay? So in general, we can come up with a conclusion that x squared plus or minus k is a shift up slash down effect. And the vertex then is going to be the coordinates 0, k, whatever this plus or minus k is going to be. And notice that the line of symmetry is still always going to be that vertical line, x equals 0. So now what I'd like to do is to come back up here. So I got is to take a look at x minus, let's just take a look at x minus 5 squared and x plus 2 squared. Okay, so now we want to see what happens when we put the constant inside the squaring. Okay, so here I'd like to make this open bracket x squared x minus 5 close squared. Okay, so we'll just take a look at this one here first, and let me just double check my windows here. I'm going to expand this to -10, and then I want to expand this to 10. Okay, now let's take a look at a graph. So here is the graph of x squared, and here is the graph of x minus 5 quantity squared. And can we notice that this graph of x squared was shifted to the right? Okay, shifted to the right. So this appears that this is a shift right. And notice that the vertex has now changed. Okay, instead of the vertex being here at 0, 0, notice the vertex now is 5, 0. And notice that the line of symmetry has changed, and this line of symmetry is x equals 5. Because notice right here, if I put my vertical line right here, then that line of symmetry now has changed. Well, if subtracting 5 shifted to the right, so let's just notice that, you may have thought, well, wow, that's kind of interesting. But notice if I put the number 5 in here, 5 minus 5 is 0, and 0 squared is 0. So it kind of will go ahead and always shift this to the right. So if this subtracting 5 shifts to the right, what do you think that this plus 2 is going to do? Well, let's take a look. So let me come over here, and let's just change this now to plus 2. Okay, and now let's take a look at the graph. So there's x squared, and notice that x plus 2 shifted to the left. So this was a shift to the left, and notice 2 units. This was a shift to the right, 5 units. Okay, so now we have this shift left, shift right going on here, and notice that the vertex is now -2, 0, because the vertex here shifted over here to the left, and notice that the line of symmetry is x equals -2. Okay, so notice that there seems to be a relationship between this x component of the coordinate, notice here, and then let's just scroll up. Notice that these guys here, right here, appear to be the same, and again here and here appear to be the same. And there is that relationship here. All right, so now we have the fact that x plus or minus k squared. All right, so for the plus it's going to be a shift in the negative direction, and for the subtraction will be a shift to the right, k units. Okay, and then our vertex is going to change. So now the question is this: putting both of these together, what happens if we were to take a look at the graph of x plus 2 squared minus 2? So what happens to the graph of x squared then when we go ahead and put both of these? Well, as we have observed, this plus 2 should shift the graph of x squared to the right 2, to the left 2, and this minus sign should take the graph of x squared and shift it down. All right. So notice that this is a shift to the left, so 1, 2, and this one goes down, 1, 2. So this is our vertex. So notice that our vertex now has an x coordinate of -2 and a y coordinate of 2. Okay. Now then, to help us out in my math lab when you actually have to start to graph these things, it's nice to come up with a second point. All right. So notice here that the vertex, if we plug in x equals -2, I think we can agree that at -2 this thing becomes 0. Okay. So to get the second point, the idea is that when you're at this point here, what happens if you move to the right one, and what happens when you move to the left one? So to make life a little bit easier, I'm going to tell you, due to the symmetry property, these two values would become the same. So let's just note that if I move to the left one, I get x is minus 3, and if I'm here at the vertex and I move to the right one, I'm at minus 1. So notice if I plug in a minus 3 plus 2 is minus 1. So notice I get minus 1 squared, okay, minus 2, which is minus 1 is 1 minus 2, which is equal to negative 1. So this one gets a value of negative 1. And if I plug a minus 1 in here, notice that I get minus 1 plus 2 squared minus 2. So here I get 1 squared minus 2 equals negative 1. So notice if I come over here, 1, come up here, and then here I come up here. So notice now I can sketch my graph, and it looks exactly like that. And then the next thing is that if I draw straight down here, this dashed line, that is my line of symmetry. So notice that we have the vertex was shifted to the left 2, okay, and this should be a minus 2, thank you. So it shifted to the left 2, down 2, so we have the vertex at negative 2, and notice that our line of symmetry is the equation x equals minus 2. So just putting these together. Let's take a look at one more. Let's suppose that we have the equation x minus 3 quantity squared plus 5. Okay. So when we go to take a look at this one here, we know that this negative is going to, this minus 3 is going to shift the graph of x squared to the right 3. Okay. All right. So we know we're going to go to the right 3, and we know that this is going to shift up. So if I shift to the right 3, so x squared, 1, 2, 3, and then goes up to 5, 1, 2, 3, 4, 5. So here is our vertex right here. Okay. So again, let's just note that if I go 1 to the right and 1 to the left, so I get x and I get my y, and notice if I go to the left I get x is 2, and if I go 1 to the right I get x is 4. So again, if I plug a 2 in here, notice I get 2 minus 3 squared plus 5, which is equal to negative 1 squared plus 5, which is equal to 1 plus 5, which is equal to 6. So for this one I'm going to get a 6, and I'm just going to tell you now, for the sake of time, that one there is going to equal to 6 as well. So notice that this comes up 1, and this comes up 1, and here is a graph of the parabola, and this is exactly what you can somewhat do with the MyMathLab, which we'll get to here in just a minute. So notice here we have our vertex, which is now 3, 5, and notice that our LOS, our line of symmetry, is x equals 5. Okay, so now what I'd like to do is to take a look at what happens when we have f of x equals negative x squared. So let's take a look at what a negative out front does, okay, and see if we can't come to some kind of a generalization here. All right, so let me clear this. So let's go up here to y, and instead of this one I'm just going to clear and go negative x squared. Okay, and I'm just going to come back over here. And again, make that a thick line. So let's press our graph, and let's just notice that our negative, look there, it flips it upside down. It flipped our graph upside down. So what do you think if we were to take a look at, for example, what if we were to take a look at negative x squared plus 4? So what do you think? That 4 is going to still do what? That's right, it's going to shift up 4 units. And then this negative should flip our graph. All right, so let's just come over here and take a look-see and see what happens. So I have my minus x squared. So now I'm going to go plus 4 and do a little graph here. And let's see, there's my x squared. And boom, there it is. See how it's shifted up 4, but then we flip the graph. Well, what do you think is going to happen if I take a look at negative x minus 3 squared? What do you think? Again, we know that this is going to be a shift to the right 3 units, and this negative should flip the graph. Well, let's verify our guess. So let's go minus, so open bracket, so x minus 3, and let's go ahead and square that. Hit the right button. All right, so let's go ahead, graph. Okay, so there's our x squared. And look at there, flipped it upside down. Our vertex has shifted to the right 3. So what do you think is going to happen when we take a look at minus x plus 3 squared minus plus 2? So let's just notice that what's going to happen is this is going to shift the graph to the left 3 units, and this one is going to shift the graph up 2 units, and then this one is going to flip the graph upside down. So we're going to take x squared, we're going to shift left 3, and then up 2, and then flip. So let's verify our hypothesis here. So here we get x plus 3 plus 2. So based on this, let's just go ahead and give a quick sketch here. So we're going to shift left 3, 1, 2, 3, and shift up 2, 1, 2, and then our guess is that the graph should look something like that, just to get a rough sketch. So let's verify. Graph. So there's x squared, and there it is. Shift to the left 3, shift up 2, and there it is. Again, notice that we have our line of symmetry is right here, and it is, so first the vertex is just what we said, negative 3, comma 2, and our line of symmetry is x equals negative 3. All right, so now we just want to take a look at one more thing, okay? One more thing, and then we'll take a look at how to do this in my math lab. All right, so what I'd like to do is to take a look at what happens when we have a number between 0 and 1. So I want to take a look at 1/2 x squared, and then I want to take a look at what happens when I have a number bigger than 1. So I'm going to take a look at 3x squared. So we're going to take a look at these each at a time and see how each one of these numbers has an effect. Okay, so I'm going to clear this. So let's go 1 divided by 2 x squared. All right, so now I'm just going to bring this back over, make that a thick line, and let's see what happens. So here's x squared, and here's 1/2 x squared. So doesn't that look like it makes the graph wider? It kind of takes the graph of x squared and kind of pulls it apart. So this one, so when the number in front of the x squared is bigger, or between 0 and 1, this will make the graph wider. Technically, the term would be a horizontal extension. All right, we'll just say wider. All right, so now let's take a look at what happens when the number is bigger than 1. So say 3. And now let's take a look at the graph. So notice it made it narrower. Can we agree? Narrower? Okay. So there you go. Notice that the vertex is still at the origin, 0, 0, and notice that the line of symmetry is still the line x equals 0. So, kind of pulling all this together, The question is, what happens if we take a look at 4x plus 2 squared minus 3? So the idea is that this plus 2 is going to shift left 2. This minus 3 is going to shift down 3, and then that 4 is going to make it narrow. Okay, so let's take a look, see real quick. So let's just sketch this out. So go over 2, 1, 2, go up 3 or down 3, 1, 2, 3. Okay, so technically our graph would probably look something like this. And I'm claiming that we should end up with a graph that's narrower. It should look something like that. Okay, so let's see, 4, open, x plus 2 squared minus 3. Okay, graph. Okay, so we can see the graph is definitely narrower than the x squared. We have our shift over here to the left 2, down 3. So notice here our vertex is going to be the point -2 comma -3. And notice that our line of symmetry is the line x equals -2. So again, the idea is that our line of symmetry is right there. All right, let's go ahead and flip over real quick and take a look at if you want, at this point in time, you can stop the video. I'm just going to pull up and do a couple of things on my math lab. All right. All right, so up till the previous part before this, that was our lesson video. So for those of you, this is a little bit of a tutorial. I'm just going to arbitrarily pick about 2 or 3 of these, so it's not overly too long, and definitely something that you can come back to. All right, so let's take a look. See, we have to graph x squared minus y, so 9. So let's just note it says use the graphing tool to graph the function as a solid curve and the axis of symmetry, the line of symmetry, as a dashed line. So this thing, right off the bat, we got to go ahead and do 2 of these things. All right. So let's just notice that this graph of x squared minus 9 just says take the graph of x squared and shift it down. So I'm going to come over here. I'm going to click on this dude right here and pop that out. So here is our parabola. So we know that we're just going to take the graph of x squared and we are going to shift it down. And again, I would encourage you, notice up here in the upper right these coordinates. So right here is 0, 9. So I'm going to go ahead and click there, and here we have to be kind of creative here. So again, notice if I move to the right one, so I'm going to come over here to the right one, and then notice that at x equals 1 we can come right over here and observe that at x equals 1, 1 squared is 1, and then we get -8. So here I'm going to get this value right here. And notice in the upper right, I have 1 comma -8. So there's my second point, and there is the graph. Now don't forget, we have to also put in the line of symmetry. I was going to come back and say no bueno. So notice that the line of symmetry is still the x-axis. So I'm going to come over here to the line tool, and I'm just going to say this point down to this point, and then I'm going to click the dashed line here. Okay, the dashed line, and then I've got everything in. So here we go, save, and you can somewhat see it, but that dashed line for the line of symmetry is there. Check our answer, we got the correct answer. And then our vertex, well, we just have to put in the ordered pair. Notice our vertex now, since this was a shift down 9 units, so we'll just type in 0 and then arrow over, -9. That should do it for us. Check our answer. Great job. And then our axis of symmetry, notice it says type an equation, x equals 0. Check our answer. Boom, there we are. So this is how we're going to graph parabolas. All right, so notice for our next example here, we have this thing here going on. So again, notice for all of these, it's going to be sketch the parabola and then sketch the line of symmetry. So again, let's just observe this 2 is going to shift the graph of x squared to the left 2 and up 3. Okay, so to the left, we'll start here at 0, 0, to the left 2 and up 3. So we want, let's see, choose our parabola. There we go. So 2, move up. So there we got our 3. So let's put that in there. So again, doing what we did before in our lesson part, notice that at the x value of -2, if I move to the left 1, so if I come over here to the left, see my coordinate over there in the upper right is now has an x value of -3. So if I plug the -3 inside, I get -3 plus 2, which is -1. And then if I square that, I get 1. And then if I add 3, I get 4. So notice that this says that at -3, I should go up to an x value of 4. So that's right there. So I got -3, 4. So there is my parabola. And now if I come over here to the line and make that a dashed line, again, I need to come over here to -2. And again, see, there's my dashed line. All right. So we got all of that in there. Click Save. Check our answer. Got the right answer. That's always a nice thing. That way we can move forward. Okay, so now we have, notice our vertex is at -2. And then we come over here to 3. Check our answer. Great job. And notice this is always the x component of the vertex, so x equals -2. Check our answer. Great job. And move on to the next. All right, for my last example, we'd like to go ahead and take a look and sketch the graph and get the information here. So you can kind of see how the math lab is going to work. Every one of these 21 exercises work fairly similar. All right. So let's just observe that this thing here is going to take the graph of x squared, shift it to the left 4 and up 2, and then we know the negative is going to flip it, and we already know that that 3 is going to make the graph narrower. Okay, so let's just see how it all fits together. So I'm going to pop this out. Okay, I'm going to choose my parabola. So again, we got to move left to -4 and then up 2. 1, 2. So again, on the upper right, again, when I say upper right, I'm referring to this guy. So 4, 2, got to get down here to 2, right? All right, so there's my starting point. Boom, got it, locked into place. Now again, if we just move to the left 1 or to the right 1, all right, I'm going to move to the right this time. So -3. So let's just observe if I plug in back to my equation, -3 plus 4 is 1. I square the 1 and I get 1 back. So 1 times -3 is -3. So now I get -3 plus 2, which is -1. So now I have to come all the way down here. Again, in the upper right on my coordinate, it's -3, comma, -1. Boom. I got to click that. So there we have our parabola. And now we come to our line tool. We'll make it a dashed line. All right, and we come over here to x equals 4 or -4. Put that in there and just come down here. Pick a second spot down here. Again, it just doesn't matter, and click Save. All right. So there we go. We got our flip. We got our thing over there. Check our answer. And we got a great job yet again. Our coordinate for our vertex is So we can see we shifted to the left 4, so we get a negative 4. And then we get a 2. Oops. Got to get it inside the blue box, I guess. There we go. Back over 2. All right. Check our answer. Boom. Nice job. And then finally, the axis of symmetry, or the line of symmetry, is x equals negative 4. I don't know why the caps is on. X equals negative 4. And check the answer, and boom! Got a lot of booms in there. Alright, so ladies and gentlemen, that's my quick tutorial on how to use my math lab. Alright, so again, if you got any questions, let me know in the warm-up, and outside of that, I will see you in the classroom. Adios.